Okay, lesson 3-6, part 2. It's still about compound inequalities, but we're going to introduce something called interval notation. So definitely take the time and write down every one of these points here. So I'll try and read them off so you can listen and write at the same time, but definitely put interval notation as your title. Okay, so that when you look back at this, you know what this is actually about. Okay, point number 1. The interval represents the interval on the number line that is shaded. So what you're going to see here is that we're going to have some, and it's going to look weird, but what I mean by that is it represents the part of the number line that was shaded. Right, part number 2. And there's 2 stars next to this, so it's very important. Numbers are the boundaries. Symbols decide if the circle is opened or closed. Now, remember that from before when we graph it on a number line? Okay, so now this next part. If you have parentheses, just regular parentheses, those are used with less than or greater than, and the endpoints are not included. Those are open circles. Like, there's a lot of stuff here. Just make sure you write it all down, and then when I actually show you some examples, it will make more sense. Okay, brackets, which are just parentheses, but they're squared off, they're used with less than or equal to or greater than or equal to, and those endpoints are included. Those would be represented by the closed circles. Okay, this symbol right here that looks like a sideways 8, that's the infinity symbol, and that's used when the interval continues forever in the positive direction. And those are only used with OR inequalities, because remember how OR inequalities, they go in 2 separate directions forever. So we're going to be using the infinity symbol with OR inequalities. And down here at the very bottom, negative infinity, that's when the interval continues forever in the negative direction. Okay, pause that if you need to copy anything else down if I went a little too fast, but make sure you have all 5 or 6 of those points there. Okay, so now I'll show you how it actually works. I think it'd be a good idea to copy down this. So you have here, you have the inequality. You have x is greater than or equal to 2. So by now we know how to put that on a graph. We go to 2, we color in the circle because of the or equal to, and we shade the numbers that are greater than 2. Well, if it asks you to write it in interval notation, okay, that's right here. So you have a 2 because that's where your number is. Now, it has a closed bracket around the 2 because that closed bracket means you're including the 2. And then you put comma, and the infinity means that you're going to go forever in that direction. Like, there is no right boundary. Because you go forever, you just put infinity. And infinity always has a curved bracket because infinity isn't a number, it's just a direction. Okay, so then number 2, here we have x is less than 2. So we know on our graph we come to 2, it's an open circle, and we shade numbers that are less than 2. So you'll see with interval notation, you always have a left boundary and you have a right boundary. Like, it's always that same order. Well, now the left boundary is actually negative infinity because it goes forever to the left. And the right boundary is 2, but this time it has a curved bracket on it because you're not actually including the 2. So the curved bracket goes with open circles. The squared off bracket goes with closed circles. Okay, now those are just regular inequalities. Now, when we get into compound inequalities here, this third one, we have 1 is less than x, which is less than or equal to 5. So that's an and inequality, but you would have an endpoint at 1, open circle. You have an endpoint at 5, closed circle because it's less than or equal to, and then you have the shadings in between 1 and 5. So your interval notation, you have your left boundary, which is 1. You have your right boundary, which is 5. Now, you're not including the 1, so that gets like a curved bracket, but you are including the 5, so that gets a squared off bracket. And then this fourth one here, this would be an OR inequality, so we have x is less than -3, or x is greater than or equal to 4. So if you have two inequalities, you're going to need to have two separate interval notations. So for the first one here, x is less than -3. Open circle at -3, and you're shading out to the left. So the left boundary is -infinity, and the right boundary is -3. But because you're not including the -3, that's why it has a rounded bracket. Now, x is greater than or equal to 4. You're at 4. You have a colored in circle because it's or equal to, and you're shading out numbers that are greater than 4. So your left boundary is a 4. It has a squared off bracket around it because you're including the 4, and because you're going forever out to the right, you have infinity, and infinity always has a rounded bracket. Okay, that's a lot of stuff there, and we'll do more and you'll get more used to it. But that's this over here, this is interval notation. Okay, so problem 5 says what is the graph of, and then it gives you something in interval notation. So we need to make a number line. So if -4 is our left boundary, we're going from -4 and then we're ending at +6. So -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. And I don't write all the numbers, I just make sure I have the spaces. Okay, so we definitely have a circle at -4. Now, because this is a squared off bracket, we want to make sure it's a colored in circle. And then we have a circle at 6, but because it's a rounded bracket, curved bracket, it's not colored in. And then we just shade in the interval between -4 and 6. So this would definitely be an and inequality, okay, because it's squeezed in between two numbers. So then the next part, it says, how do you write the interval from -4 to 6 as an inequality? Okay, you got to think. There's no infinity, so it has to be an and inequality. So stick x in the middle. Well, we knew that we knew our boundaries are -4 and 6. So if we know x is less than 6, and we know x is greater than or equal to -4. So it's almost like the same thing. You take this -4, and you take this 6. Because this was curved, it doesn't have a line in it. Because this was a bracket, it does have a line in it. Okay, what is the graph of the interval from -2 to 7? So we make a number line. We have -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, open circle on -2 because of the rounded bracket. Closed circle or colored in circle at 7 because of the squared bracket. And then it's the interval between that, so we shade between those two boundary points. And then how would you write the interval from -2 to 7 as an inequality? Again, this has to be an and inequality because we don't have it going out to infinity. So you stick x in the middle, you stick -2 on the left, and 7 on the right. We know that x, if we read it from the x direction, x is greater than or equal to -2, and x is less than 7. Okay, now how would you write x is less than or equal to -1 or x is greater than 2 in interval notation? Sometimes it's easier if you graph it first. So if we graph this one, it's an or, so we have -1, and it's saying x is less than or equal to -1. So we want to color that in, and we want to shade out the numbers that would be less than -1. -1, 0, 1, 2, and then x is greater than 2. Not colored in circle because we're just greater than 2. Okay, so because we have two separate inequalities, either up here we had two separate things, or when you look at the graph, there's two separate lines. You need two separate interval notations. So when we do the first one, think of your left boundary and your right boundary. Well, your left boundary is going out in the negative direction forever, so that's negative infinity. And your right boundary is -1. Because it's a colored in circle, or because it's less than or equal to, it's a squared off bracket, and infinity is always a rounded bracket. Now the next part, our left boundary is 2, and our right boundary is positive. I always make my infinities look too much like 8s. It's like a sideways 8. Okay, 2 is going to have a curved bracket because it's just greater than. It's an open circle, and infinity always has a curved bracket. And then it says, what does the graph look like? But we've already done the graph. So if you can't do this without graphing, just think of you could always draw a number line really quick, but if it's x is less than or equal to -1, you know you're going to have the numbers less than -1. So that's got to include negative infinity, and then if it's greater than 2, it's going to go 2 for forever, so that's going to be positive infinity. Okay, and that's it.